Okay, let's cover some quick advanced techniques for truth tables. These are called indirect truth tables. And maybe the main reason I like to teach these is because sometimes you want a quick way to check if your larger truth table, your more formal truth table, is accurate. And so this is a nice little, slightly less formal way of addressing this question. So here is the general idea. What you can do is take set up an argument. Here it is: if A then B, if B then C, if C then D, if D then E, therefore if E then A. So there's the argument. We're going to lay it down like that horizontally, and we are going to perform indirect truth table analysis. We only need 2 rows, one for the argument itself and one for a truth value assignment that we will devise. Step 1. Form the hypothesis that the argument is invalid. Recall that if an argument is invalid, it is possible that the premises are all true and the conclusion is false. Thus, if this argument is invalid, then there must be a consistent assignment of truth values to the sentence constants of the argument that makes the premises all true and the conclusion false. In practical terms, all this means is that we should set our final columns for this here argument such that the premises are all true, but the conclusion is false. Remember, if you're to find this particular row on any of the larger truth tables, you don't immediately that this argument is invalid. So what we're going to do is begin with this assumption and see if we can establish it. Okay, let's move on. Step 2. Test the hypothesis by trying to fill in the rest of the truth tables consistently based on the hypothesis that the argument is invalid. If it is possible to assign the truth values in such a way that the premises are true and the conclusion is false, with no contradictory assignment of truth values, then the hypothesis is verified. If it is not possible to consistently assign truth values so as to make the premises all true and the conclusion false, this would show the argument is valid. Okay, and in practical terms, what we have to do is try to see if we can fill this table out, but always making sure that if we decided that A is true, then it should be true wherever A appears. If we decide that B is false, it should be false wherever B appears. That's what it means to be consistent in your truth value assignment. So, let's begin with the conclusion, because the material conditional, the horseshoe, has a very peculiar truth table. It's only false when the antecedent is true and the consequent is false. So that is the only possible truth value assignment we can give to E and A. That's it. That's the only time the horseshoe is false. Okay, now we have to, wherever we see an A, put a false, and wherever we see an E, put a true. So far so good. Our truth value assignment, or our TVA, is consistent. Okay, let's start from the left now. We have there premise 1, if A then B. We have a false antecedent, and the horseshoe says the whole compound should be true. It actually doesn't really matter what we put in the B column, because if you have a false antecedent, the compound is going to be true no matter what. So let's just put a B there because it works. Why not? Okay, now that we've done that, wherever else we see a B, we have to place a true there as well. Okay. Now let's look at premise 2. The B column is true, the horseshoe is true. We actually only have one choice as to what to put into the C column. It has to be true. Had we put false there, the whole compound would be false and we would mess up the horseshoe. But the horseshoe is already true, so C, the only thing it can be is true. Okay, if we've decided that C is true, then all C's must be true. And we are left with the same conundrum here. We have the whole compound being true because the column for the horseshoe in the third premise is true. So we have to make the D true as well. Oh, but since we decided that we are making that D column true, all D columns must be true. And there it is. You have completed an indirect truth table. You have been able to devise a truth value assignment where the premises are true, they're all true, but the conclusion is false. In other words, you have proved that this argument is invalid. That's how that works. That is it, my friends, for truth tables. There will be no more truth table techniques in this course. I should add, though, that there will be, if we want to call them the descendants of truth tables that we'll be seeing. It's hard to describe what we're going to get into next until you really start doing it for yourself. All I have to say right now, though, is that I think it's going to be a lot of fun.